My name is Matt Clough. I'm from Richmond. And I am currently the web lead at an awesome product shop in town called MobileX, where for about 4 years now, I've been working with all those great folks making some cool stuff for the web. And that's a summary of what we do. So let's start with this image. Imagine you're in this scenario. You know the feeling your notebook is in front of you, open to an empty page. You've just finished picking ornamental fall vegetables, peeling fresh cinnamon bark. And now you're enjoying some tea and getting ready to write. But you're afraid to even put your glasses on because you're not sure where to begin. Or maybe this is what you're looking at, and you only got as far as choosing Calibri for your font, and you're thinking of calling it a day. Or maybe you're trying to design something, but you can't stop stressing about all the plugin updates that are available for you. But I imagine for most of you in the room, you're probably looking at something more like this. You're ready to start a project, and you know this one's going to be really good. It's going to be really clean, really well written, amazing, in fact. And people are going to write Medium articles about it. It's going to be really good. So you get some base level scaffolding in. You've got your package.json because you know you're going to need that. You got your scripts, your styles. You're just going to use CSS this time because your styles will be so efficient that your whole style sheet will be no more than 1 kilobyte. So you add the nav, has a drop down, of course, no problem. There's a link to the contact form. Nah, that's going to be a mail to instead. So now you need to get that drop down scripted. So you go into your single JavaScript file. You're just going to do one. And you write a small amount of JavaScript. And then a day passes. And next thing you know, you're responsible for explaining how this code base works to everybody on your team. But you really do not understand it anymore. It makes absolutely no sense. Thinking about your code as design can potentially keep you out of this sort of mess. So today I want to talk to you about designing code. We're going to talk a little bit first about what design is, how it can be considered a creative practice, and how code itself is or should be considered design. So first of all, what is design? I'm going to do a few definitions, because why not? Definition 1, a plan or drawing produced to show the look and function or workings of a building, garment, or other object before it is built or made. So when we think of design, we often think of like graphic designers, fashion designers, architects, interior designers, industrial designers, these kinds of things. This is sort of our typical idea of design when we hear that word design. Just look at the kinds of images you get when you do an image search for design student. So if you meet someone and say, I studied design, chances are you're probably going to think of a graphic designer. And you can tell that this guy is a graphic designer because of the color swatches, the drawing tablet that he has, and the wooden mannequin, I guess, that he has there. It's a key graphic design implement. But our own language betrays that idea because when we use phrases like designed to be easy, or designed for quickness, or designed with lawyers in mind, the iPhone isn't rose gold with the Apple logo on the back to make it easy. Nikes don't have a swoosh to make you faster. And I have no idea what this one is about. It could just be visually appealing for lawyers or something. So let's look at a different definition. Purpose, planning, or intention that exists or is thought to exist behind an action, fact, or material object. I like that one a little bit better because design, for me, is intention. Consider a maze. A maze is designed to be difficult to navigate. So when it's three-dimensional, it has walls that look the same. You can't see over any of them. There's no obvious direction to go. And there aren't any indications on where you should be going at all. Now consider a road. A road is designed to be easy to navigate. It's flat, it's open, it has painted indications to reflect headlights in the dark so they can be seen from your car. But design is more than the visual and the concrete. So Take UX design, for example. It's a really confusing term for a lot of people. If you talk about UX design, say you're a UX designer, people often wonder what that even means. It's hard to explain in the context of design because there are often no visual products that come out of UX design. So graphic design sometimes accompanies it, and you get these sort of wireframes. But that's not really the product of UX design, is it? It's more about the user experience. UX design describes itself really well when you lose this conception of design as a purely visual thing. It's user experience design. You're designing the user experience. Is design creative? That seems like an obvious one. I think everybody would say yes. But now that we're talking about design in sort of a non-conventional sense, I guess, it's worth addressing. What constitutes creativity in all the forms of design? So design has a goal, and it has constraints. I know I just said design is intention, but it's more like the product of a goal and constraints, which I guess technically looks like this. Sometimes those constraints are self-imposed. For example, the latest version of the Twitter logo was intentionally designed with only the use of circles, or sometimes the constraints can be environmental or contextual, like these Adobe structures built by the ancestral pueblos. Print design can be constrained by surface and an ink, the quantity of surface and inks, the types of surface and inks, the structural quality of surface and inks, the interaction of certain surfaces with certain inks, and so on and so forth. Working with constraints to accomplish a goal necessitates creativity. If we understand creativity to be ingenuity. But creativity has been somewhat separated from ingenuity in our collective consciousness. So if you came to my talk last year, you know I'm a huge fan of stock photos. They're sort of a weird reflection of what the average person in this audience understands about the world, which is why they're so weird. But if you look at stock photos for Ingenious here and compare them with stock photos for creativity, you can really see a difference, especially in these light bulbs. So you've got the creative light bulb and the Ingenious light bulb. Creativity is often seen as a more emotional and obscure thing compared to ingenuity, but it's often appreciated for that. You get these sort of artist personas as being creative and weird and misunderstood. My coworker recently shared an arcade game with me that was made in 1987. It's called Darius, I think. I'm not really sure. The game was a huge deal because it fit inside this insane 12:3 aspect ratio, all inside of an arcade cabinet. Now, it also had some pretty dope promo materials like this one. You can kind of get a sense of the screen inside of this arcade cabinet. It's pretty wild. But in 1987, screens in that shape and size, let alone anything approaching widescreen, didn't really exist. So the solution was to use not one screen, but 3 screens in a row. The biggest problem with that in 1987 was that CRTs had these huge bezels that you couldn't really stack together to make a seamless screen. So instead of putting them in a row, they came up with this ingenious configuration, creative configuration rather, which the middle screen faced straight forward and the 2 side screens were underneath the middle screen, bouncing off of a 2-way mirror through which the middle screen was looking through. So you ended up with this effect. And this is actually a picture of an older, not super well maintained machine. You can kind of see that the mirror is dirty and it's misaligned, and then the illusion is kind of broken. But I just think it's a really good example of creativity making way for ingenuity, I guess, the merger of the two. So how does any of that relate to code, and how is code designed? Code is a product. So consider your phone, and I assume this is everyone's phone here, right? It's a piece of industrial design. Consider the innards of that phone. There's several pieces of electronics that are all put together in a way that is, to some degree, easy to disassemble. Maybe not super easy. Probably got to pry it open a little bit. But a lot of the wires aren't soldered together. They plug in, they snap in, they clip in. The inside and the outside of the phone both have this intention. The outside of the phone is designed to be comfortable to hold, comfortable to keep in your pocket, nice to look at. Software on the phone is the same. The innards are designed to be easy to use as well. So lots of people work on these phones. They either put them together or fix them for you at a repair facility. And it's hard to make sure that everyone's going to be able to do that with the amount of people that work on these phones. So the innards of this phone are designed to be usable, designed so that everybody can access this. There are countless forms of design that go into a phone, and these are actually just some of the ones that they name on the Apple website, which I thought was a long shot to find it, but there they just had it listed. So code is the same, and any given package.json can be taken as sort of a list of products that have been designed for others to use. And I'm sure you all use node modules pretty frequently. And whether it's a personal project or something that's larger, that a larger team is going to be working on, code should be designed in a way that's easy to use, scalable, and adaptable. So how, though? How do you design code? I thought this tweet from the organizers was pretty funny the other day. It caught me off guard. It was mostly the wording. Can code be creative? Wasn't really the central idea of the talk when I set out to make this talk, but it kind of steered me in that direction. It is a good question, though. The answer is no, but also yes. If you work with designers, you're probably used to getting comps. And from those comps, you're probably pretty used to building out what's in the design. You may be so in the motions of building out comps and so used to sort of how you put a website together or whatever it is that you're building that the goal is already clear and you know how to approach it. And from that standpoint, you're sort of using your code as a predetermined toolkit. In some cases, you're not allowing yourself to be creative with it. So when you look at this design, you're looking at the end product of it, especially if you work in a waterfall environment. When you get the design, the goal of this design has already been more or less realized. But you're starting at the beginning. The beginning can be daunting. You have to decide what to do first, what technology you're going to use, what architecture is going to look like. But like I said, sometimes it's not actually that hard to start. You've probably done it a few times, and you sort of know what you're going to do. You can get going. You can write a few functions, make drop-downs work, all that stuff. You're looking at the design, so you know what you have to build. You probably need to get some data, and then put that data someplace, and then you'll probably write a handful of pretty similar pieces of code to finish the build out when until you cross that finish line. But chances are you've finished a project before, totally frustrated, wishing you could just start over or spend the next 6 weeks fixing everything you just did. Does that sound right? Raise your hand if you've felt that way before. OK, that's like everybody. Cool. Something I like to think about is futuristic design, particularly in anime, and particularly cockpits in anime. So everything looks really easy. All the controls look really easy. The interfaces are super easy to understand. You look at it and you're like, wow, that's a totally believable future. I've never been in a spaceship, but that one seems familiar and easy to use. I don't know, it looks like a car or something. But when you compare it to the reality of aerospace technology, it's completely different. There's there's not a chance I could figure out what's going on here. And so that, I think, is a shuttle. And this is just a commercial jetliner. Still looks pretty crazy. The fiction becomes more apparent when you look at the reality. How much amazing stuff do we use today do you think was inspired by science fiction? It's not that hard to guess. All these people, this video is funny because they're both talking about Star Trek, sort of unprompted, actually. And I know Steve Jobs has mentioned in the past he just wants everything to be Star Trek. Start with your ideal. So when you are designing something, when you're Steve Jobs or Bill Gates, and you think about Star Trek, and you think about the technology, and they're thinking, man, I want to build that. That's my ideal. Work towards your ideal. Write the code that you want to use. You're designing a product, and your code is the interface. And it's all just text. It can read like code, or it can read like prose. It's your choice. Start with something readable, understandable, digestible, and even fun to use, and work from there. Design obviously has constraints, though. Some of your constraints might come from the comps, the product spec, client's requirements. But the only constraint that code really puts on you is the language itself, and any arbitrary conventions that might come with that. So a fun example of this that I heard of recently, and I don't know if anybody was at the Ryan Florence thing about a month ago, I guess, the React Suspense API. And I'm trying to keep things not specific to React. I write a lot of React. Who writes React in here? OK, so that's a good amount of people. Anyway, so in summary, the Suspense API allows a React app to surface one spinner or placeholder while content is being fetched within the app. So instead of having to manually manage spinners for everything you're trying to fetch, the API provides this lightweight cache and a function that creates data fetchers. The data fetchers interact with that cache. The fetchers always try and get data from the cache first, but if there is no cache data, they'll throw. The placeholder component that we're looking at here wraps everything in the app and catches anything that throws, and then surfaces a spinner once it catches. In this component, there's one key in the state called promise. The state gets used in order to render, state is used in the render function to show the spinner if there is a promise in the state. Otherwise, it just renders the rest of the app, the children of that component. Where it gets interesting, though, is that in the component did catch lifecycle, and this is a method that gets called on a component whenever one of the child components throws. But in this case, the fetcher doesn't throw an error at all. It throws a promise. So the promise is set in the state, causing the spinner to render. And then when the promise is resolved and the data has been fetched, the state is reset and the spinner goes away. This API isn't that complicated conceptually. Maybe complicated to write. To understand, it's not. But it's gotten a relatively large amount of buzz from what I can tell just from the idea of throwing a promise in code. It's creative. Throw is typically reserved for errors, but at the end of the day, it's really just one way to deliver data to a catch. So consider your patterns. When you're designing code, you should always consider your patterns. The patterns you create and whether or not you use them, and you should design them and use them, will go a long way in affecting your finished product. Pattern creation it can be a good way to use some creative license in your coding. So if code syntax, things like primitives are pretty inflexible, patterns are only limited by how you actually use those things. There's a few standard patterns that people use, and I'm sure a lot of you are familiar with these: modules, prototypes, observers, singletons. Modules, obviously being the encapsulation of reusable code, whether it's code written and exported from a single file or written as an immediately invoked function expression by wrapping everything in a function wrapped in parentheses and executed. The prototype pattern encapsulates code as a constructed object, either using a function or an ES6 class, which has the same result. The observer pattern is probably pretty familiar to anyone that's used Redux before. Data gets transmitted through the code by calling functions on subscribers. So in this case, the Redux store has a dispatch function called with an action, which is pretty much just an object literal containing a type and a data payload. And the subscriber reducer is then notified about the action, and it uses a switch to react to that action. The singleton pattern describes a single instance of an object. The most basic is obviously the object literal. The most convoluted is something like this, in which an immediately invoked function expression returns a single instance of a constructed object. All of these things are pretty conventional patterns, and some of you have probably used them. Some of you may not consider them patterns, but just how you write JavaScript. But they are patterns. You can make your own patterns. You don't have to use these patterns. So consider your patterns, but beyond considering code patterns or conventions, consider actual patterns. A good pattern is easy to follow. So looking at a pattern, almost anybody can look at it and continue it. They know what the rules are. They can just look at it and figure out how to keep it going. But code bases can be pretty big, and at the outset of development, a code base could and maybe should be considered indefinitely large. So how do you look at your pattern? Draw it. That's one option. Actually draw it. I am in the habit of keeping a notebook by my desk. Drawing code helps me work out a lot of things and understand what I'm doing. This is a really weird example, but I just happened to find a picture of it on my phone for some reason. I was looking for something a little clearer, but that's the kind of drawing you can do to just help you out. So let's look at a more fleshed out version of that, though. So this is a diagram of the current state of a front end I'm working on. It's definitely got some problems. But being able to look at everything all laid out like this, it becomes a little clearer what the problems are. The tree here is the render tree, and the arrows indicate where data requests and responses are coming and going and how they flow. But I know what all these things mean looking at it. It's hard for me to separate myself from it. They don't feel like they're entirely out of place, but the design obviously could use a lot of work. So what if I abstract this whole thing into shapes? It looks even crazier than it did before. Kind of looks like a Rube Goldberg machine, or flying spaghetti monster, something. Each shape that I've got here is standing in place for one kind of node on that tree. So if I analyze this pattern and ask myself, how would you continue this pattern? I have no idea. Looking at these shapes, if I didn't know anything about what they stood for, I don't know what's going on here. I can't continue this pattern. So it's clear, looking at this, though, that these shapes are virtually the same in the way that they work in this, whatever this pattern is. But there's only one instance of the sort of stripy shape happening. These are also virtually the same, but the stars are less consistent in number and how they're used in the pattern. These two are pretty much the same, but the triangles exist in a concrete collection, whereas the diamonds seem to have no logic at all as to where they are on the tree. So if I then remove all these redundancies, I can start to see something more sensical emerging from this. So if I take what I have here and simplify it, I can get a good stand-in as a base model for a slightly more streamlined design for this architecture. Another tactic, prototype it. So if you don't draw your patterns, or after you've come up with a pattern, you can, and you probably should, prototype it. I have an anecdote for this. My first attempt at designing a pattern, I did in Angular 1. Haven't used Angular since. So you're going to see some funny stuff probably. I was still pretty green as a developer at the time. We were working on a pretty big site that seemed like it had some impossibly complicated interactions and transitions, and the whole thing was meant to be this single page app with like route transitions and everything, and this was probably 4 years ago. I was in over my head with it, but I was having a lot of trouble connecting the UI to all the various controllers and all the pieces of the UI that all the changes affected. There were a lot of changes happening. Then I found out about Angular's emit and broadcast methods. So to me, this seemed like it would let me notify all the other controllers about events without having to directly code in subscriptions. So for example, when some button was clicked, I would broadcast a show thing event to the root scope. And then in the scope, I would get the event data and affect some kind of change. It was very creative. It seemed like a really good solution to all the problems that I was having. And it came at a really good time because the project was getting dangerously close to launch, and I was having trouble managing my state in this massive app, which you may have noticed was also combined with jQuery. So then I had to scale up this pattern, and then I ended up with something that looked like this. And you can just imagine that it scrolls all over the screen. And then that sort of had me feeling like this for the next 2 weeks. Probably lost a few weeks of sleep on that one. So prototyping, test your pattern on a small scale. If you have a hot idea, try it at a small scale first. Then you can go crazy with it. If you're working on a team, it's safe to always assume that what you've just created is going to be scaled up indefinitely. Maybe it will, maybe it won't. Maybe you know that you don't work on huge sites or projects, but you don't know that. It could get bigger. There are tons of sites that are really good for prototyping, but I honestly feel like none of them really help me focus on the important stuff like CodePen. It's an older site for this kind of thing, and it's pretty bare bones. It's got one HTML file, one CSS file, one JavaScript file available, readily available. I think they've made a thing where you can link CodePens and import stuff that way. But to my knowledge, I think they only let you use a limited set of preloaded node modules. So some other sites like this will let you use any node module you want. And to me, I feel like that gives me too much freedom to make bad decisions when I'm prototyping. So then, of course, the step that I'm assuming all of you have been anticipating is test it. Testing is another good starting point for code design because it forces you to start with your ideal. For the uninitiated, and I am newly initiated to testing, so don't throw things at me. I'm sure a lot of you have opinions. But the workflow for test-driven development goes something like this. Write a test that fails, make that test pass, and then repeat. So in testing, you can even begin to imagine and concretely define what your ideal looks like before you even write the code. So you can start with a test, does it exist? This existence test fails, so now I need to make it pass. So I go in, write a function called makeOfTheSite, and export it, and now my test is passing. So now I repeat. The ideal function should not only exist, but it should get all the data. This new test fails because I haven't made it do that yet. And that's just sort of I'm sure a lot of you test, but if you haven't, that's what test-driven development looks like a little bit. Interestingly, though, testing frameworks, I think, are some of the most well-designed code out there. The interface and syntax sort of read like a memo. They describe the piece of code, what you should expect from it. It should exist, therefore I expect it to exist. It should do great things, and therefore I expect things to be done when I run it, and I expect those things to be great. And this, to me, is a good example of what it looks like to start with your ideal code. It seems like whoever wrote testing frameworks just wrote some code that sounded good to them, and it works well. It reads like a sentence. You know exactly what's happening. Get it? So the next time you start out writing a code, any code, whether the architecture for an entire project or a single utility function, think about how you want to use it and how you want others to use it. This is your robot anime, and as a JavaScript person, you're only limited by some of the most loosey-goosey syntax out there. That's all I got. Thanks, folks.